Okay, folks, let's do another run through of some example work and kind of interpretation. Now, you're probably aware that this is actually an assembly drawing where parts are shown and listed in a, basically a parts list or a parts schedule. The item number is identified, typically the quantity is provided just for pricing or collection. Part numbers are issued if they have them within some type of database. Descriptions are great. And this actually has a little bonus. This actually has the length of the parts, which is very kind of uncommon for a parts list. Usually the amount of information it's going to see is right in here. But let's take a look at what all else is associated with the drawing. First off, you'll notice that the drawing itself is representative of an isometric drawing where the parts are already assembled, or in place of how they should be assembled. So we'll zoom in just a hair here and fire up our handy little screen draw tool. So we see a couple things. First of all, we see the identification of the part number. So this is item 6, a S-beam beam 3.5 by 6, which is an S-beam actually. You'll notice that it is clearly connected to this part, probably across the base there. And so we might be interested in seeing what type of welds were used to put together, although we don't actually see a weld connection between these 2 points. We do see some welds, however, along, let's see, here's one, with item 4, this rectangular tube. It doesn't have a weld. I just called it out. Looks like the diagonal strut brace. Looks like item 3, possibly, is right here. And we have a joint there. Looks like the only things that we're seeing on the welds, honestly, are the joining little flanges, which I believe are part 5, which are gussets. By the way, in case you don't know what a gusset is a triangular plate, typically, piece of metal, that is used to literally do what it's doing here, and that is to create a strength point between a joint of 2 parts, typically. We use gussets for a lot of different things, but whenever you see a triangular feature, that pretty much is a gusset in a corner. You will notice that this particular gusset right there, which you can assume is also the same one as right here, is a lot of times they're not going to show it time and time again, they're just going to help it be understood, is welded, as you can see, with a what type of weld? Hopefully you said fillet weld, and you'll notice the size is provided here. Now, it says 3. Now the real question is, what does that 3 mean? Does it mean 3 inches? Does it somehow mean 3 millimeters? What's going on there? And if you'll kind of look at these values, you're probably going to notice that this looks to be a millimeter based or a metric based drawing, not an English drawing. So 3 millimeters, or I guess it could be, no, it couldn't be, it'd be too thick for centimeters, so I guess it almost has to be millimeters, is potentially the size of the weld. In either case, we would be interpreting whatever they have correctly in the fact that we're saying, all right, we're going to do a fillet weld, and we're going to do it 3 units of some type of size. So, basic little assembly drawing, not too hard, not too difficult to understand, pretty straightforward. Let's check out another one. Alright, I like this one. Now this one doesn't seem to have any welds on it, and it's a little bit grainy, but I want to use it because of the fact that it shows a more complex assembly. Now there's nothing really special about assembly drawings other than the fact that they provide parts lists. This is pretty common for everything. They provide views of the parts being assembled. Now you'll notice that this is actually what we call an exploded view. And the explode, of course, exploded. There we go. And exploded, of course, means that although the part does get assembled into one complete component, by showing the parts disassembled and sort of offset from each other, it makes it easier to understand and, of course, delineate what part goes with what. So there, we would look for part 1, we look for part 4, part 3 from our parts list, and they also provide different views. For example, this view of the part is looking from that direction. It looks like this is likely to be the top view looking down, and you can kind of see how these parts are pushed together. So this is a common assembly view. No welding here, but good for interpretation and just a little practice. Okay, so what we see here is a partial assembly drawing. Well, I should say that. What we're seeing is a drawing that is going to be a component to assembly, but it's not complete, but it's going to be good exercise for us. Now this is obviously not an exploded view. This is a simple, straightforward assembly of a part system with the weld shown on it. So this is actually might be something more akin to a weldment drawing or a fabrication drawing, more so than just a straight up assembly for a collection of parts. Who knows? Because they didn't provide the whole thing, this is all we got to work with. But the good news is we get to do some practice runs with our actual welding interpretation skills. So obviously we have several parts. Obviously part here, part here, part here, and they're not called out on this drawing, but that doesn't matter, we get the idea. And we do get to see some weld symbols. Now this is a nice weldment drawing because of the fact that we get to see how all the parts are supposed to be in a nice isometric format. We're seeing these parts and it's clearly understood what's going where. So it's not a lot of visual interpretation that's necessary to figure this out. On the plus side also we have some great examples. So for example, you see this by 2 right here, or x2. That of course means that there is going to be 2 cases of this particular weld, which is nice. Now this can also be replicated by doing it this way. So they have their fillet weld, they have an all-around symbol here, they have the size of 3/16, but they draw the arrow to say we're going to do it here and do it here. Why did they not do a by 2 in this case? It's because it's not an identical joint or not identical setup. This by 2 right here is an identical setup from this side to the opposite side on the part. This is a different type of connection, although it's going to receive the same type of weld with different features. So you can see the difference of why they used by 2 here and not in this particular case. Same story is true for this particular scenario, although this is even more similar. It's actually, one might say, well, that's on both sides of the part. It is on both sides of the part, but it's 2 different type of I shouldn't say it's 2 different type of parts connecting to the primary part. So if we call this primary part 1, we've got part 2, and we've got part 3. Part 2 and 3 are not the exact same size apart. Even though the weld's going to be the same, that's just going to go all the way around the lower one and all the way around this one, it's not the actual same, so that's why, again, they don't use the by 2 factor here. They just draw 2 different arrows, which is pretty typical. Okay, this is another example. What we see is another assembly sort of drawing, a weldment drawing, where we're going to actually throw the welds to it, and we get some great applications too. Now this is a symmetrical part, so that does provide some advantages. Notice that we have a by 2 right here, and it's pointing to this point, this connection, and this connection, but it's not showing it over here. That is the implication. So by pointing the by 2, in this particular case, we're saying that you're going to do this weld here, and you're also going to do it here. And the same thing is true for this one. Since everything is symmetrical, what happens on this side is going to happen on that side as well. Same story here. We've got a weld here, so it's going to happen here. You'll notice though we do have this fillet weld, which I think may actually be a slight mistake. Can you figure out what the mistake is? Well, I don't know this for sure, but my guess would be this should have an all-around symbol on it, simply because this is a cylindrical part that is obviously welded into a plate, and so what they're implying is doing a fillet weld, but they're implying it doing here. Now, the interpretation could be the fact that, well, since it is already circular, then obviously we're going to go all the way around it anyway, so maybe they could have left it off, but it wouldn't have hurt to actually throw on the actual all-around symbol so that there's not a misinterpretation potentially of that. But it may not be a mistake, maybe okay, and logically it is okay, but it's one of those things that you probably would likely see people put an all-around symbol on it. Looks like we got a fillet weld, both sides. In this particular case, can't tell exactly what's going on right there, so it's almost like it's going to be welded on this edge and possibly down below. This particular case, notice that this is not a symmetrical situation. They're going to weld here, they're going to weld here, but they are not going to weld, in a by 2 situation. They're not going to say by 2. They're going to say this side or this side and this side. So since the parts are symmetrical, it is the same part here and here, then therefore the other side is going to be welded the same. So this is relying on the symmetry without having to do the by 2, simply because the part has both sides. Okay, see the difference there? That's why they didn't have to do the by two, because they're just going to say this side and or other side and arrow side, and since the part is connected to the same side, same plate on both sides, it allows them to get by with that. So that's a good example too. And by the way, if you have any questions in this, always remember that you can email me or send messages for interpretation or clarifications. Just make sure that you list which video it's on and also the time of which the question may arise or what you're pointing out. So that helps me a whole lot. All right? All right, like this one, looks like some kind of hopper system, maybe some kind of scoop, I'm not sure. Anyway, I'm going to zoom in just a little bit here. And let's take a look. So again, we've got a weldment drawing, the parts are already pre-assembled, and we are seeing what we need to see. So for example, we've got some fillet welds, got some variety of groove welds with our square groove, and let's see what we got. I got a bevel groove there too, fillet, and let's see. Of course, actually we had double bevel or bevel both sides. So we've got some good information. Now, what's interesting is that this one is similar to our last case, where they are saying all the way around and both sides. So they're going to weld on this side and this side with the fillets. Now, if you look at this case, they're going to weld. Looks like some part is attached to some part. Can't tell exactly what's happening there, but it looks like there's an extra piece that is welded to these plate systems. And we've got a square groove, obviously, and of course it's showing on the arrow side, which would be the top side, welding down. Same story in this case, except that you see they have the two. So this welding symbol gives us the ability to handle both sides by just pointing the arrows there. This one is going to be done by saying, hey, we're doing this here, we're doing this here, and we're going to be doing it by two. So there's going to be another instance of this weld. So let's see if we can figure out where the other instance is, or actually the other dual instances of this weld, because by pointing the arrows at these 2 points, that means they're going to weld there, but by saying it times 2, it means it's going to happen somewhere else. Most likely on this back side back here, which would be the symmetrical equivalent to where we're actually pointing to. So these 2 arrows point out, technically this is representing 4 welds is what it boils down to. 2 on this side, and then 2 on the symmetrical opposite side of the piece. And looks like we've got our bevels going to occur there all around and on both sides. I'm not sure exactly how that part works, so who knows. That's okay though, sometimes we don't always have all the information that we need. But we're going to throw the groove weld to it in the case of the bevel, and we're going to do it all the way around and on both sides. So probably, this is just my guess, this weld's going to occur on the outside and potentially on the inside of the part all the way around. Right. So over here, pretty simple standard situation. We're going to also do our bevel, and we're going to do it along this surface and along this surface. Okay. So these kind of exercises are the best way for you to kind of really get your handle on interpretation. So we're going to do some more as we go along. Right now is a great time for hitting a break. So we'll stop there and see you on the next one.